again, zeros of polynomials. Nothing is changing as far as the process. We're still going to use synthetic division. We're just going to have to come up with that factor or that zero on our own instead of it being given to us. Okay, and what we're going to be using is this theorem called the possible rational zeros theorem. And what it is, it's a list of possible zeros. It doesn't mean that all of them will be zeros. It just means if there are rational zeros, they're going to be in this list. And that list, we're going to call it a P over Q, and I'm going to show you on a polynomial which one's P, which one's Q. Some numbers from that polynomial. And on the top is going to be the factors of the constant. And on the bottom will be the factors of the leading coefficient. Maybe we know what those mean. If they don't, it's not hard. First thing we're going to do is just list the possible rational zeros, and then we'll use them later. They always, the last couple of years, they've always put at least one question in the course exam that is just make the list. Not even do anything with them. Just make the list of possible rational zeros out of that. In college algebra, we do this as well. And every college that I've taught for and every college algebra course that I've been a part of where I didn't even make the final, the college that I was working for did. Every one of them had final exam questions that were make this list. And it's really easy to make. And the work to do anything with it is exactly what we've been doing. But making the list is really easy. So I want to show you how to do that first. So let's take this polynomial. F of x equals x to the third plus 2x squared minus 11x plus 12. Okay. So we're going to look at the same things that we looked at yesterday and the day before with the polynomial. First thing we're going to make sure of is that it's in descending order, and then we would look for a GCF if there happened to be one, because that's going to make our list easier to make. And it's also, if there's an x in common with everybody, we wouldn't even have a constant value, so we would need to factor that out. So you're always going to look for that GCF. If it's x, you're going to factor it out first, and then look at what's left and create your list from that. So when we look at the constant, for thinking about our P over Q list, our list of possible rational zeros, which part of that polynomial is the constant? Which one doesn't have a variable? 12. 12 doesn't have a variable. If something doesn't vary, it's constant. Okay, so the 12 is the constant. The leading coefficient, where do you think that is? Front, leading, right? It's in descending order. What's in front? 1 in front of the x cubed. So the leading coefficient is 1. The constant is 12. So that's what we're dealing with here. So 1 is right there. That's going to be our Q. The constant is on the end. That's P. So P is the constant that's on the end. Q is the leading coefficient, the number in front of the highest power of x. Okay. Now, this one's pretty easy because Q is 1. That makes the list easier to make. If Q is something else, we got more stuff to do. But Q being 1 is not hard. So P over Q, we want the factors of 12. What are the factors of 12? What's that even mean? Things that multiply to be 12. So what things multiply to be 12? All right, I heard several there. I heard 4 and 3, 6 and 2, 1 and 12. All of those things are factors of 12. And I put a plus minus in front of that because technically positive and negative would work there as well. So like -1 times -12 is also 12. So plus or minus is technically in front of each one of those numbers. But I'm good with just putting plus or minus in front of the whole list. I'm just saying, hey, guys, we know that that's plus or minus. Now, on the bottom, we want the factors of the leading coefficient. The leading coefficient is 1. What's the only factor of 1? 1. So that makes this easy. There. Now, that makes the setup. Now, the list is actually doing that division for each piece. Okay? So this one is pretty easy because you're only having to divide by this one factor on the bottom. We'll do one in a second that's got more than one factor on the bottom, so the list grows then. But so we're going to take each number that's on the top and divide it by 1. And that's going to be a number that's in our P over Q list. So the list is this set. So I'm going to use curly braces to denote a set. Notice I'm putting a plus or minus in the front. Technically, you're probably going to see, if you looked in a textbook or looked this up online somewhere, you would see them put a individual plus or minus in front of each single number. But we know this means the same thing. So I'm going to let you do some shorthand stuff there. Okay, so 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3, and so on. And our possible rational zeros for this particular polynomial are this list of numbers. So what we've done is taken a polynomial that we don't know a whole lot about, but we've narrowed down all of the possible solutions in the world from every number down to a list of 12 numbers that could be a rational zero for this polynomial. That's taking it from a million, like billions and, even more than that, an infinite number of possible solutions for this polynomial, and we've cut it down to, it could be, if it is a rational zero, then it's going to be one of these 12 numbers. Positive and negative 1, positive and negative 2, 3, 4, 6, and 12. Okay, and then we're going to do something with that in just a little bit. So this is your P over Q list, your possible rational zeros list. That's what we've created there. I'm going to show you in a little while what we're going to do with that. So I want to be able to build that list first, and then we'll do something with it in a minute. Let's look at another example, one that's got a different leading coefficient, maybe a 4 in the front. Okay, so here we have a polynomial. It's in descending order. We make sure that. Does it have a GCF across the whole problem? No, so that doesn't affect what we're doing. We always kind of look for that because it could reduce our numbers, make them smaller, or it could get an X out of the way so that we even have a constant out of that. So let's get our factors of P and Q. So what goes on the top? Now, yeah, the factors of 10. Don't really worry about the positive and negative part of the 10. Just think of that number. It's a 10, positive or negative 10. Yeah, that really doesn't affect it. But what are the factors of 10? 1, 2, and 5, and 10, right? What's the leading coefficient? 4. So what are the factors of 4? 1, 2, and 4, right? So there's 3 things in the denominator this time, right? So that means we're going to have to do every one of these on the top divided by 1 are going to be part of our list. So our list is going to have 1 divided by 1, 2 divided by 1, 5 divided by 1, and it went off. Awesome. Internet's great today, in case you didn't know. Working wonderful. There we go. All right, so take a deep breath. All right. So take each factor that's on the top, divide them by 1. That gets you part of your list. Then take each factor that's on the top and divide by the next factor. So 1 divided by 2, that's the fraction 1/2. That's a rational number. Rational number just means you can write it as a fraction. So that's what we're trying to find here. And then 2 divided by 2 is what? We've already got that written, right? No need to write it again. 5 divided by 2. Does that go evenly? No. So I'm going to write 5 over 2. I don't have that one listed yet. 10 divided by 2. Already got that one written, right? So I don't have to write it again. Okay? So I've divided each factor by the second factor in the bottom. Each factor on top gets divided by each individual factor in the bottom. So one went into all those to get the first 4 numbers that are in my list. 2, we wrote the ones that we didn't have already. 1 over 2, 5 over 2. The rest of them worked out to be ones we already had. Then we're going to divide each one of these 4 numbers on the top by 4. 1 divided by 4, 1/4. We don't have that one yet, so we're going to write it down. 2 divided by 4. Half, we already got that one, so we don't have to write it again. 5 over 4. We definitely don't have that one yet. And 10 over 4 would be 5 over 2. We've already got that one, so that's the end of our list. So our list is a little larger, and it has some fractions in it here because our leading coefficient was a number that had more than a factor, more factors than 1. Okay. So anytime your leading coefficient is a number that has a lot of factors, your list is going to get longer. That's our P over Q list. Okay. Now, so what we've done there is we've narrowed down the possible rational zeros for this particular polynomial from every number in the world down to this list of numbers here. Okay. Now, when I was in high school, we didn't have the luxury of having the graphing calculators. We had some here. Miss, I don't know if any of y'all know Miss Patricia Campbell, teaches over at SCA. She was my math teacher all through high school. And she had like 10 graphing calculators. They were TI-82s, was the model number that they were on at the time. They were great, wonderful, not as nice as the ones you guys have now, but they were great calculators. But there weren't enough to go around, so everybody couldn't use one. So this is what we had to do. We had to check every one of those to see which ones worked. You guys have the technology of a graphing calculator. It's going to help us narrow that list even further because we know something about the graph of a polynomial and what a zero of the graph means. Okay, so instead of having to do synthetic division with each one of those individual numbers to see which ones work, I can use the graph to shorten my load a little bit and get one that works automatically. Okay, so let's look at an example that we're going to do that with. All right, so I'm going to go to example C. We're going to take a fresh polynomial and just go all the way through finding all zeros of the polynomial. So we talked about this the last couple of days. Hey, what's a synonym for zeros? X-intercepts. That's the important one. That means when we graph this polynomial, if we find a zero, what should it be? Where should it be on the graph? On the x-axis somewhere. That's going to help us when we go to figure out what to use out of that list. So x-intercepts, zeros. Another word they use is roots. That you might see that sometime. So roots, zeros, x-intercepts, all the same thing. X to the third power minus 8x squared plus 11x plus 20. Okay, so this one in particular doesn't factor. If I try to do grouping to solve this, we've done factoring to try and solve higher degree polynomials. We did some synthetic division in the last couple of days but we had to be given something to do that. Here we're given this polynomial. We're not given anything about it. We're just looking at it and we're saying, okay, what are my options for solving it and finding the zeros? Well, if I tried factoring, this one doesn't factor by grouping because the first pair has a very common factor of x squared, but the second pair doesn't have the right GCF so that we could group. So it doesn't work to factor that. So this is where the rational zeros theorem and doing synthetic division comes in. So let's make our P over Q list. So what goes on the top? Factors of 20, which would be 1, 2, 4, 5, 10, and 20. On the bottom, factors of 1. So that makes this list pretty easy. The list of possible rational zeros are only 1, 2, 4, 5, 10, or 20. If it crosses the x-axis at a rational number, it will be one of those. Positive 1, negative 1, positive 2, negative 2, positive 4, negative 4, and so on. It'll be in that list. That's what we're finding when we make that list. Now, the next step that you would want to take in order to solve this polynomial is to graph that polynomial. Like I said, when I was going through this, we had to just guess. Pick one and guess. And see if it, and do synthetic division. If it worked, great, you got lucky. If it didn't work, pick another. Do synthetic division. If it didn't work, pick another. All right, and there's some other clues that you can use that we would go through if you were going to have to do that. You guys have a graphing calculator, so let's graph this polynomial. I'm going to go to my graphing calculator. I'm going to hit y equals, and I'm going to get rid of that logarithm thing. We ain't done that yet. So let's type in that polynomial. X to the third power, so x raised to the third power minus 8x squared plus 11x and then plus 20. Okay? And I'm hitting graph. And I'm going to make sure my screen is 10 by 10 there. Zoom 6, get you there. How many places do you see that crossing the x-axis? 3. So that means we will have 3 real solutions to this one. Now, where is it crossing the x-axis? Looks like at -1, looks at positive 4 and positive 5. Okay? I just need one of those to get me started. Pick the one you think is the easiest. I'm pretty good at multiplying by 1. This happens to be -1. That's not that much more difficult, right? So when I do synthetic division, I'm going to do it with the -1. This will work no matter which one you pick. I'm picking -1 because the math's easy. If you picked 4 or 5, it would also work. Okay, so I'm going to put a -1 on the shelf, and I'm going to do synthetic division on that polynomial. Okay, I'm picking -1 because the graph goes through the x-axis at -1. And I thought the math would be easier to do with -1 than it would be 4 or 5. Because I know I got to do multiplication. Not that 4 and 5 multiplication tables are difficult, but we can do them. Okay, 1's pretty easy. So drop the 1 down and multiply. 1 times -1 is -1. Add -9. Multiply 9. That's 20. And that's -20. Are we surprised that the remainder is 0? Shouldn't be. All right. We saw it crossing the x-axis when we graphed it. So we're not surprised that that remainder is 0. Now, our quotient is a quadratic, x squared minus 9x plus 20. If we set that quadratic equal to 0, so we get x equals -1. That's one of our zeros. We proved that by our synthetic division. We saw it on the graph. We proved it by our synthetic division, got a 0 as the remainder. The next step is take what's left and try to solve it. Okay? Because this was a cubic x to the third power at the beginning, when we do that synthetic division one time, it breaks it down to an x squared. And then that allows us to use all of our tools for quadratics. We got factoring, we got quadratic formula. I don't care which one you use. Use the one you're best at. But remember, factoring doesn't always work. Quadratic formula does always work. This one will factor, but not all of them will factor. So breaking that by factoring, that'd be -4, -5. That's x minus 4, x minus 5. We set those equal to 0. We know how to do. X equals 4. X equals 5. Where else did we see that thing crossing the x-axis? Positive 4 and positive 5. So it should not be a surprise that we see those numbers there. Okay? They happen to all 3 of the answers here ended up being rational zeros. That is not always the case. We're going to see some that don't do that. But so don't get in the habit of just saying, "Oh, I saw it on the graph. It looked like about 4." It could have been, like square root of 7 or something like that. That was where it was at, but it wasn't 4. So you can't just bank on getting your answers straight from the graph. So there are zeros. We had 3 of them. What was the highest exponent in the problem? 3. We got 3 answers. Isn't that how it's supposed to work? We talked about that the last couple of days too. That no matter what is going on, we should end up with the same number of answers as we start with the highest exponent. Look at another one. F of x is equal to x to the 3rd power minus 4x squared minus 15x plus 18 this time. All right, P over Q list. This one should be easy because the leading coefficient is what? 1. So that makes the P over Q list super quick and easy. It's only the factors of the constant. What's the constant? 18. What are the factors of 18? 9 and 18. Okay. Somebody asked Siri what the factors 18 are.
You've triggered it.
Do what?
You triggered my Siri.
I triggered your Siri.
Yeah.
I wish I triggered your math enthusiasm. I'd go for that better. All right, let's go with our setup for synthetic. So I'm going to set it up, and then what do we do next to find out what to put on the shelf? Put it in the calculator graphic. Find out where it crosses the x-axis and pick you one. Okay? So let's graph that one. Y equals, just going to clear out that one, x to the 3rd minus 4x squared minus 15x plus 18. Hit graph. And look for somewhere it crosses the x-axis. Where does it cross the x-axis? 1 is an answer. -3 looks like it's an answer. And +6 looks like it's an answer. I need to pick one to do the synthetic division. 1 would be the easiest one, I think. So let's use that one. +1. Drop that down. Go to work. 1. And there's that remainder of 0. Should not be surprised by that. Zeros, we get x equals 1. We think we're going to get x equals 6 and x equals -3 out of that. Let's prove that that's what happens by taking this quadratic and factoring it. -18 had to be -3, would be -6 and 3. That's x minus 6, x plus 3, minus 6 equals 0, x plus 3 equals 0. Hey, we do get x equals 6. We do get x equals -3. We get all of those zeros there. Happened to be, again, another one that had all rational zeros. That's not always going to be the case. Understand that if all of them are rational zeros, you're going to see every one of them on the graph really nicely. So that's always a good checking point and something that can help. Okay, that won't always be that way. Let's do the next one. See one that doesn't do that. It's kind of got a mix of stuff. So example E, g of x, 9x to the 4th power plus 3x cubed minus 30x squared plus 6x plus 12. So this one, the P over Q list, not going to be quite as easy because we've got a leading coefficient of 9. So that means we're going to have some fractions involved in our P over Q list. But we're going to make that P over Q list because we're going to see some things on this graph that are going to be kind of in between some places. And we may need to have some fractions involved to be able to deal with that. So P over Q Factors of 12 would be 1, 2, 3, 4, 6, and 12. Factors of 9 are 1, 3, and 9. So our P over Q list is going to be all of those 1, 2, 3, 4, 6, and 12. And then we divide each thing by 3. So that's 1/3, 2/3, 3/3 is 1, 4/3, 6 over 3 is 2, 12 over 3 is 4. We've already got those. And then do the 9, 1 over 9, 2 over 9, and then 3 over 9 is 1/3. I've already got that. 4 over 9 I don't have. 6 over 9 is 2/3. I already have that. 12 over 9 is 4/3. I already have that. What could I have done at the beginning here that would make this easy? I skipped.
Took out 3.
I could have factored out a 3, and that would have made my numbers for my P over Q list much smaller, right? Yeah, that would have probably been a good idea. Not going to mess us up if we don't do that, though. Okay? It just makes it easier if you do take the GCF out. So if we'd taken that out, we would have had 3x to the 4th plus x to the 3rd minus 10x squared plus 2x plus 6. And then that would have, all that would have done was eliminated that factor, and that would have eliminated the 12 and anything that had a 9 in the bottom of it. So it would narrow it down a little further. On the P over Q list would be much shorter there because we factored out that GCF at the beginning. Okay, it's not going to mess you up if you forget to do that. Okay, unless the problem asks you for the P over Q list only. Okay, as far as solving it goes, we're still looking for where this polynomial does what? Crosses the x-axis. That's the end result. Whether you pull the GCF out or not, it's going to cross the x-axis at the same places, no matter if the GCF is pulled out or not. Okay. Now, let's do some synthetic division with this polynomial. I'm going to go to the original one where let's just use the GCF one there, the 3x, because the numbers are smaller. 3, 1, -10, 2, and 6. I need to go graph that original polynomial, see where it's crossing the x-axis. So, graphic calculator, y equals 9x raised to the 4th power plus 3x to the 3rd power minus 30x squared plus 6x plus 12. So I'm graphing the original. That's what I'm graphing. All right. Got some stuff going on there. Where am I seeing it cross the x-axis? Looks like -2. Maybe looks like -1/2. Could it be -1/2 or +1/2? No, it's not in our list. So it couldn't be that. The only things it could be over there on the right-hand side are maybe +1, or right here, this could be maybe -1/3. I don't know. I can hit trace and then type in -1/3 and see if I get a 0 for the y, and I don't. Maybe it's -2/3. Trace -2/3. Enter. Nope, not -2/3. It's not either of those. If I type in +1, so trace +1. Hey, +1 works. Looks like -2 works too. So if I hit trace and then type in -2 and hit enter, I've got 2 things that I could use here. Now, let's use +1. That's an easy one to do synthetic with, right? So that would be a good reason to use it first. Break that down. 3, 4, -6. What did I do wrong here? Something's went wrong. Because I divided by 3, not 2. That's right. I didn't do my division right when I factored out the 3. So that should be a 4. And then it does work. -4, -4, and there's a 0. Now, here's where we run into a problem. We broke down an x to the 4th power with a synthetic division. What's the quotient? X to the what power? 3rd power. Do we have a lot of tools for x to the 3rd power? We've got some, but we don't have as many as we have for an x to the 2nd power, right? Got a lot of tools for quadratics. So here's where how many places did we check that were good numbers where it crossed the x-axis? We had 2 numbers. We had the +1, and then what was the other one? Look at your graph. -2. So we can do synthetic division again with a -2. We're going to do that synthetic division on that quotient. So I'm just going to make me a little bracket here, and I put a -2 right there. Okay, so right now I've already proven that the 0 is x equals 1. I'm going to try to prove that -2 is a 0. Here's the rule of thumb that you're looking at. Look at the highest exponent on the variable in the polynomial. This one is what? X to the 4th power at the beginning. The original problem. Okay? Subtract 2 from it. That tells you how many synthetic divisions you need to do. What's 4 minus 2? 2. That's how many times you need to do synthetic division. Okay?
On all of them?
On any problem. That'll help you. Like, so x to the 3rd power, like the previous problem, 3 minus 2 is 1. How many times do we do synthetic division? Once. Okay. X to the 5th power, 5 minus 2 is going to be 3. Maybe we can do 3 synthetic divisions. That's what you're shooting for, to try to break the polynomial down into something that's x squared, because we have a lot of tools for things that are x squareds. We don't have nearly as many for things that are x cubes, unless it's maybe a sum or difference of cubes. We got a tool for that, but we don't have much else. Okay, so if I pull the -2 in there, it'd be -6, that's -2, that's 4, that's -2, that's 4. Hey, there we go. X equals -2. Now we've got a quadratic. We got 3x squared minus 2x minus 2, and we're setting that equal to 0. Options. Can I try to factor that? Yeah, -6 and add to be -2. There's nothing that does that. So I've got to use quadratic formula now because that factoring did not work. Okay. So quadratic formula, you guys remember that? X equals -b plus or minus radical b squared minus 4ac divided by 2a. Okay. So 2 plus or minus the square root of -2 squared minus 4 times 3 times -2 over 2 times 3. That's going to get us our other 2 zeros, x-intercepts, roots, solutions. Okay, so that'd be 2 plus or minus the square root. 2 squared is 4 plus 24 would be 28 over 6. We're going to break down 28. 4 and 7, 2 and 2, pair of 2s. So it's going to be 2 plus or minus 2 radical 7 over 6. And that will simplify to be, because all 3 of these numbers on the outside are divisible by what? 2. I can simplify that to be 1 plus or minus radical 7 over 3. Is that a rational 0? No. The square root of 7 makes it irrational. Okay? On our graph, this is not a number that's in our P over Q list, right? Obviously, it's got the square root of 7 in it. None of that had that, right? But those are zeros to the polynomial. If we go to our graph here, we should see that thing. That's one of those numbers, is that one right there between the -1 and the 0. Let's say trace, and it's 1 let's say minus the square root of 7. And then divided by, I should have put parentheses around the 1. Put that in there. And then divided by 3. Hey, look at there. The y value is 0, and that's where it's crossing. The other one would be the 1 plus the square root of 7. So we converted that to a decimal. You don't want to use a rounded decimal to check that with, because it won't be perfect. You got to use that exact solution to check that with. All right, so we got zeros. 1, -2, x equals 1 plus the square root of 7 over 3. X equals 1 minus the square root of 7 over 3. And I'd be okay with you writing, 1 plus or minus the square root of 7. Just listing it out completely. Let's see what's going on. Okay. Long? Yeah. Easy? It's kind of medium. This is not incredibly difficult. It's not. If you understood what we did the last 2 days, this is just adding a couple of things to that. It's not that bad. Let's do one more and see how we do here. So f of x, let's make it seem shorter. X to the 4th minus 22x squared minus 75. P over Q list is pretty nice for this one because the leading coefficient is 1. It makes it a little easier. But 75 is a pretty big number, so it's probably got more factors than if it were a 3 or something. So. What are the factors of 75? 3 times 25, right? Oh, don't forget 15 goes into 15 times 5 is 75. 25 and then 75. So it's not that long. 75 is not. If it were 72, 72's got a lot more than that one does. Okay, so there's our possible rational zeros. So we don't have a whole lot to try here. But what would be our next step? Put it in the calculator, graph the thing, and see where it's crossing the x-axis. That's what you're looking for anyway. So equals, clear that one out. X raised to the 4th power minus 22x squared minus 75. All right, so that in, and you're hitting graph, and we're seeing that thing cross the x-axis in a couple of places, but that's all we see. It's possible that maybe there's some further out, but not likely here because those look kind of conspicuous in the fact that they're equidistant from the center. The first one on the left here would be at -5. So if the other one's at +5. And a lot of times when that's happening, it probably doesn't turn around and do some other stuff outside of those. But you could zoom out if you wanted to and see if there's anything else. I promise you there's not on this one. So we only see 2 places it's crossing the x-axis. But how many answers should I be finding? 4. Huh. Interesting. I thought it should cross the x-axis in 4 places. Let's see what's going on. So to see what's going on, let's do that synthetic division. So let's set it up for using, I'm going to use the +5 first because it's easier. Positives are always easier to use. So +5 on the shelf. And then what's my row across the top?
0.
Yeah, -75. Don't forget your zeros. You don't put those in there, it could cause you an issue. There are some times where it works out. If you don't put them in there, it works okay, but a lot of times it doesn't. So drop that, work it. 5, 25, so that's 3. 15. That's 75. And hey, what do you know? The remainder is being 0 right there. That looks good. But because the degree or the highest exponent on the variable was 4, we know 4 minus 2 is 2. So that tells me I probably should do synthetic division 2 times. And I already know one of the other numbers that I can use. I can use -5. Put that down. Hey, there's a 0, and then that is 0, so there's a 3, and then that's -15, and hey, there's my remainder of 0. So I have zeros. X equals +5, x equals -5. And I'm going to get some more. What is this quotient here? What's the equation that goes with it? X squared plus 3, and I'm setting that to 0. How do we solve that one? That's a pretty easy solve. Yeah. So move that 3, so you get x squared is equal to -3. And then do what from there? Take the square root, but when I take the square root of -3, I round up to 3, right? And so we have zeros at complex numbers. Do complex numbers show up on the graph? No. Yes. What are you talking about? At the beginning? You could do X method absolutely on that at the beginning because it's a trinomial. Yeah, great idea. Don't forget, it brings up a great point. All of these things that we've done so far are related to exactly this. That if you take the X method way of factoring that and getting x squared, 2x squared polynomials to work with, you get the solutions to those the same way that we did this. You're going to get the exact same answers. So no matter which method that you use, that would work. That's perfect. That's exactly. Tying those things together that we've done so far work wonderfully for this. Okay. There are going to be some where you can't do that, but look for ones that you can because it's a lot of times quicker to do it that way. And that I'm fine with that. Perfectly fine with that. I want you to see those things. That hey, the things we've done before still work. It's math. Been working for a few hundred years now, so it's still the same. All right. So things we're doing today. So everybody get one of those and kind of just go over what we're doing here and remind you of some things as you're going here. First 5 on there, all you're doing, P over Q list. Don't solve them, just get the P over Q list. That's all I'm looking for on the first 5. That's what I want you to be able to do. Just practice getting the P over Q list. On 6 through 20, you're solving. Now, we've got a new method of solving here with the synthetic division using the P over Q list and the graph to help us get started and use synthetic division as well. We also still have all of those other things that we've done. Factoring. I see a difference of cubes on there. If you want to use it, you can use that way of factoring to get there. But solving is the main idea here. And then you're going to run into some that you can't do you can't do that part on it. You're going to have to use the synthetic division on. Okay, so look for ways to solve this. Don't forget about the things we've already done because those still work for problems that work with that sort of style of solving them. But some of them need this stuff to do. Okay, so working on those, we got about 33 minutes left in class, maybe something like that. So get a good chance to get started with this.